All right, I feel like such a neglectful math teacher because, and I feel like we all do this kind of, not intentionally, but I feel like when you're talking about square roots of things, and this also happens, well, it really happens with square roots primarily. This is like kind of like what you should remember pretty easily, or try to remember as much as you possibly can when you're doing square roots, because these are the numbers that you have. So kind of just like 1 through 15. And then these are those perfect squares, which is the number squared, or the number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc., all the way down to 225 on this paper. But when we think about the square root of something, here's the square root symbol. So as you can see, it kind of looks like a division symbol, but it is not. And so when we're looking at it on a calculator, I'm just going to pull my calculator here real quick. If I'm looking at it here, this is the square root button, as you can see. So in this calculator, it looks like this. If you see it on your calculator without the X, which is a lot of times what the calculators look like, you should probably see that. So you should be familiar with it. But the problem is with the calculator, when you're doing these with the calculator, primarily when you have non-perfect numbers, because a lot of the times you should know these ones, these particular ones are like the primaries that you should have a good handle on. But I really feel like we do a disservice with square roots as math teachers, because sometimes we neglect the fact that it's a number times itself. So yes, of course, when you hit a calculator on the square root button on a calculator, you end up with a positive number. And these are the positive numbers. So if you do the square root, I'm just going to show you this real quick. If I do, let's say 16, and I hit the square root button on here, you can see that it comes out as 4. That's the only answer it shows you, which you can see on this paper, it shows you. But we're kind of going like on the backwards version of this. Like what happens when we square root each of these numbers? Well, what's the number that it multiplies by itself to get this? But what we forget about sometimes is the fact that it's not just the positive numbers that come up in the calculator. The negative numbers are also included in this. And so when we're looking at these numbers, you have to consider it's not just plus, or the positive 1 times 1 that gives me 1, but it's also negative 1 times negative 1. It's positive 2 that times positive 2 that gives me 4. Also negative 2 times negative 2 gives me 4. So when you're looking at square roots of any kind of number, in all reality, it's not just the positive number that you get in the calculator, but it's also the negatives as well. So you can put the plus and minus sign in front of each of the numbers, because you should really think about that. I know that a lot of times we're dealing with things like silings and things like that, and so we only use the positive values, but they really do have the negative values as well, but we kind of neglect them a lot of the time. So I'm just going to point that out to you guys as you're learning about square roots, or maybe you have learned about square roots already, but you kind of forgotten about these negative and positive numbers. And it always happens with any kind of an exponent that you're dealing with that's an even number, because anytime you have a positive and a positive, you get a positive number. You do a negative times a negative, you get a positive number. Anytime you have a set of 2, so any kind of components that are like 2, 4, 6, 8, those are all even numbered exponents that would give you a positive or a negative value that will still give you the same result of a positive square root. If you want more questions like this, find them on my YouTube channel, YouWantAlgebra. Check these all out under YouTube, Instagram, and TikTok. At YouWantAlgebra, playlist is Roots and Exponents.